All right, last time we had started section 6.2 and all right, we had just talked at the very end last time about the definition of subtraction and about subtracting like and unlike, subtracting with like and unlike denominators. And so let me flip to that slide. This is the last one we had ended on. We talked about the fact that it's pretty much the same thing as addition. We just have the subtraction sign between them. Everything else matches. So we're going to do an example, and we're going to talk about a case where it's a little bit more complicated to do subtraction with the mixed number approach than it is to do the addition with the mixed number approach. And I'll show you in this situation where and how that happens. Okay? So we've got Martine, and she buys 8 3/4 yards of fabric. She wants to make a skirt using 1 7/8 yards, pants using 2 3/8 yards, and a vest using 1 2/3 yards. How much fabric will be left over? So somebody tell me generally, like, what am I going to do with this problem? What is my goal here?
To find out how much you used and how much you didn't use.
Okay, so we could find out how much we used first, and then use that information to find out how much we didn't use. So what would we do if we do it like that? I think that's a good approach. What would we do?
You're going to add up all the different measurements you're going to use.
Okay, so that means the 1 7/8 plus the 2 3/8 plus the 1 2/3. And then what am I going to do after I add those up? Subtract them from the beginning of value that we had, which was 8 3/4. So this right here is a description in mathematics, right, about what we're going to do. I put parentheses around the values that we're going to add together first, because you guys said that that sounded like a good approach to you. And then we'll do the subtraction after the fact. Everybody good so far? Okay. So I'm going to show you the mixed number approach, and the reason I am is because, at least I'm going to start with that one, is because it's a little bit less familiar to you, probably for most of you. And then I'm going to show you the improper fraction approach, and we'll look at that one and kind of look again at some of the pros and cons of each of them. Okay, so starting with the mixed number approach takes the idea that we add the whole parts together first, the 1, the 2, the 1 here. And we're ignoring the 8 3/4. We're not dealing with him until much, much later. Okay, so ignore him for the time being. So I still have my 8 3/4 out here in front, minus. So what is 1 plus 2 plus 1? 4. Fantastic. And 2 of these fractions are easy to add together. Which 2? 7/8 and 3/8 becomes 10/8. So I'm going to put a plus sign. We've got 10/8 here. And I've got a 2/3 here. There's a couple of different things I could do at this point. Somebody suggest something that you would like to see happen next. Okay. We can find a common denominator, right? If you didn't want to find a common denominator right now, what else could you do? We could reduce the 10/8. And because 10/8 has the ability to reduce, I kind of like that approach because then my common denominator will be a little bit smaller. So I think let's do that before we do the common denominator so we don't have as big a denominator to deal with. So what would 10/8 reduce to? It would be 5/4. Now, it's okay. We can leave it as 5/4. If you don't want to leave it as 5/4, what could you do? You could write it as 1 1/4. Okay, do you guys want to do 1 1/4 or do you want to leave it as 5/4? 5/4? Okay. The next thing we're going to do then is the common denominator, and I'm going to do it with that visual that your book has going on for us there, which looks like that. So this would be 8 3/4 minus, now I have 4. 5 times 3 is 15. 2 times 4 is 8. And 4 times 3 is 12. Okay, so now I've got the 8 3/4 at the beginning, minus 4, plus 15 plus 8 is 23 over 12. Okay, at the point we are right now, the 23 over 12, we've sort of gone on long enough with not reducing. Now we need to reduce something. So we're going to reduce that, not reduce, but turn it into a mixed number because it's that time of the day. So we're going to take 23/12, and how are we going to rewrite that? 1 and 11/12. So what's actually subtracted inside if I simplify now? Okay, everybody good so far? So what we did when we did addition is that we added the whole number parts, we added the fractional parts, correct? And we can do that with subtraction as well. But does anybody see sort of a problem with that? They're going to need the same denominator. Okay, let's do the whole number parts and get the same denominator, and then I'll ask the question again and see if there's anything else that jumps out at you. So we've got the 8 minus the 5, and we've got the 3/4 minus the 11/12. And I'm going to avoid the books where we do the crossing and the denominator approach on this one, because the denominator is going to be what with the 4 and the 12? 12. So I'm just going to multiply the first fraction by 3/3. So this is going to give me what? Yeah, I'm going to have 9/12 minus 11/12. And that subtraction leads to a negative number, correct? Okay. And that's okay. I mean, we could work with a negative number, but somehow we've got to consolidate this back all together. I mean, that is going to happen at some point. So let's imagine what you would do if you dealt with money. So you're at the grocery store and you need to pay money, and you don't have exactly the right change. Well, what if you gave them $1 and they gave you back some change to make exactly the right change? Would that be okay? Yeah, I mean, you needed the exact change to go use a vending machine or something like that. So you needed it in quarters, so you give them $1, they give you back 4 quarters. That's essentially what we're going to do here too. We're going to take one of those 3 values in front. So we have 3 numbers, 3 whole numbers in front, right? We have the whole number 3 in front, and we're going to borrow from it. So we're going to take one of these numbers, and I'll write it as the 1 just for the moment. And just like I could turn it into quarters, I can turn it into 12ths. Right? It's making change. So I've got my 2. I've got my 12/12. I've got my 9/12. And I've got my negative 11/12. So now can I take 12 plus 9 minus 11 and have a positive number? Yeah, I can. So what do I get if I take 12 plus 9 minus 11? 10/12. We'll reduce that. This is our last step. What is 10/12 reduced to? 5/6. Good. And this is what? What are my units on this? Yards. This was yards of fabric. The only real difference here, we had a lot more numbers, but the only real difference here is that we have this borrowing thing going on because the subtraction ended up giving me something negative if I just used it as was. Let me show you. So there is sort of this weird borrowing thing. There's nothing I can do to tell you that that's not weird. I mean, that's a little bit awkward in this particular approach. We're going to do the same thing, though. We're going to try it with the with the improper fractions approach and see how that works out. Okay? So I had 8 3/4 minus 4, my number is not 4, 1 and 7/8 plus 2 and 3/8 plus 1 and 2/3. Okay. So we're going to deal with everything inside the parentheses first, and then we'll deal with the stuff on the outside, just like before. But with the improper fraction approach, we need to get them all to be improper fractions. We can change the 8 and 3/4 too at the same time. So let's start with the 8 and 3/4. So I would do multiplication here, right? And then addition. So 4 times 8 is 32 plus 3. There's the 35. Yeah, 35 over 4. 1 7/8. 8 times 1 is, plus 7 is, so this is 15 over 8. 2 3/8. 8 times 2 is, 16 plus 3 is, 19 over 8. We might want to even combine those two before we actually get to going with common denominator here in a minute. 1 2/3. 3 times 1 is, plus 2 is 5. So this is 5/3. So is everybody okay with me combining the parts over 8 before I move on? Okay. So 15 plus 19 is 34, maybe? There's something else pretty nice that we can do if we recognize it here. Does anybody recognize something that would be nice to do? I would reduce. Again, if we can reduce something, we can avoid bigger fraction denominator, bigger numbers in the denominator of our fractions. Get my words in the right order, and that'll be helpful. So I think let's reduce that 34 over 8. What will it reduce to? What are the numbers both divisible by? 2. So we're going to divide them both by 2. So what will we get? Yeah, 17 over 4 plus my 5/3 still. This is considerably cleaner than when we began. No question, right? No question. But now I need common denominators. And it's still the same 12 that I got when I did, over here. I mean, over here I got a common denominator of 12. Here I get a common denominator of 12. It's the same problem. If I had failed to recognize or just hadn't sort of been wanting to do it that way, I would have a common denominator of 24. That'd be okay too. I just have bigger numbers to be working with. So I'm going to cross multiply and do it from this perspective. So I have the 35 over 4 out front minus, what is 17 times 3? 51 plus 4 times 5. 20 over 12. This is 35 over 4 minus, what's 51 plus 20? 71 over 12. Now it's possible the 71 over 12 reduces. Certainly they're not both divisible by 2. The only other possibility besides 2 or 4 would be 3. So does 71 divide by 3? It doesn't. So we can't reduce that one. But it's good for us to check that. The next thing that we can do is we could actually do common denominators here again. Again, I could do the cross multiply like I did just a moment ago, but I don't think that's probably going to give me the smallest fraction possible, right? We could multiply by 3 over 3. Now we get to do 35 times 3, which is what? 105 over 12 minus 71 over 12, which is what? I don't even know if I have it written down. I do. 34 over 12. Do we get to leave it like that? Oh, look, I can reduce it. 34 over 12. They both divide by 2, right? So what will that become? 17 over 6. It's friendlier. Do I get to leave it like that? No. Why don't I get to leave it like that? I mean, I told you last time that there are some times when I get to leave it like that. Why can't I in this problem?
Because you solved it.
It didn't start with improper fractions. It started with mixed numbers, so our answer will have mixed numbers. So if we divide now, 17 divided by 6 is 2 with a remainder of 5 out of the original 6, and it is yards. Okay, so we don't have any weird borrowing going on. I mean, that's sort of like the upshot of this one. That's a plus. The bad part about it is that there was some point in there, I mean, imagine that you used a calculator because you really didn't want to multiply the numbers, they got a little bit big. Right? And if you had not recognized reducing somewhere along the way, they would have gotten even bigger. So that's sort of the drawback to this approach. So it's up to you unless you're told to do something specific, okay? All right, estimation. Estimation with fractions. There are fractions that are called convenient fractions, and these are just fractions that are roughly equal to what we're given, but they're easier to work with. So this is definitely an estimation. This is not actually simplifying to the exact same value. It's simplifying to something that's convenient. Now sometimes it tells you what kinds of numbers are your choices, almost like multiple choice. It'll say, which of these 4 choices is the closest simple fraction to the one you're working with? And it'll say like 0, 1/3, 2/3, 1. And you have to pick one of those, okay? But sometimes you just get to pick whatever sort of makes sense, whatever works. So some convenient fractions are written here. This is certainly not an exhaustive list of all convenient fractions, but it is some of them. So you have the numbers where you have numerators of 1, denominators are different. You have the 2/3, the 3/4. You'd have things like that. So they're fractions that sort of are familiar and that we're comfortable working with, or at least more comfortable than others. So let's take an example. We're going to find an estimate to the following fractions. We just get to pick, period. And we want to know if our estimate is high or low. And so in terms of the high or the low, you can make that determination in several different ways. We'll talk about that. But let's just do the first part, which is finding a convenient fraction first. So if you're taking a look at the number 12 over 78, what might be something that you can do to estimate this to get a convenient fraction? What is this approximately equal to? There's a couple of things you could do. 12 is awfully close to 10, and I like 10 better because it's got a 0 in it. You could do 10 over 80. If you do 10 over 80, what does 10 over 80 actually equal? 1/8, and it's a lot easier to work with 1/8 than it is to work with 12 over 78, right? Now, you do have sort of the weirdness that you rounded 12 down to 10 and you rounded 78 up to 80. Did anybody notice you guys did that? I mean, that was the closest number, so I understand it. But it was a little awkward. So you might also have done something where you rounded the 10, or rounded the 12 to 10 and rounded the 78 down to 70, just so that you're rounding both of them in the same direction. You could do that. And in terms of deciding if it's high or low at this point, you're welcome to use your calculator to get decimal approximations to compare. We haven't actually talked about decimals. That's our next chapter of this textbook. You can also think about, in terms of the problem itself, what you did. So like if you think about taking the numerator, and if you make a numerator smaller, does it make a fraction smaller or bigger? When you make a numerator smaller, it makes the fraction smaller, right? It's like saying I had 12 cookies. Now I'm going to pretend like I only have 10 cookies to divide. Well, that's fewer cookies, right? So I'm going to get less food, okay? So in changing the numerator and making it smaller, the fraction got smaller. What about the denominator? We already talked about this once today. When we take a denominator and make it bigger, because that's what we did, what does the whole fraction do? The fraction also gets smaller because you're dividing it amongst more people. So it's just like saying I had 12 cookies and 78 people. Now I have only 10 cookies and 80 people. People are going to get less food, right? So this estimate right here, is it a smaller estimate or a bigger estimate than the original value? It's smaller. So the estimate is low. It's smaller. All right, next one, part B. Sorry, I was looking at a note I had, but we're good. All right, 2 over 1001. Make it what? You could do 1 over 1,000. I didn't mean to put equals. Let me fix that. You might do something different. Okay, so you might choose to keep it as 2. 2 over what might be helpful? It'd be easier to do 2 over 1,000, which would reduce to what? 1 over 500, right? Which of these estimates is closer? The second one's a little bit closer, so I kind of tend to like this one a little bit better. This is one of those ones that if you've got a problem, it may be that multiple choice where the best closest approximation is actually 0. I mean, this is very, very small. Agreed? I don't want to split 1 cookie among 500 people, or 2 cookies among 1,001. Okay? So it might be one of those kinds of problems. I like the value of 1 over 500 probably a little bit better. But it's an approximation. Either way, you've got something that's an approximation. All right, we have to decide if it's high or low. So, what do you think? High. So why would we think that it's high? What did you do to decide that?
Because 2 divided by 1001 is 0.0019, and this is...
So you looked at fractions, okay, or decimals. What did you do?
It would be 0.0019.
Okay.
This is
Okay, so Madison chose to look at a decimal approach to it. And we haven't actually talked about that, but there's nothing that you have to justify for this. You're just telling us if it's high or low. So our estimate here is that it's high. One thing else you could do in thinking about it, looking from here to here, if you're using this value, is that we changed the denominator only, right? We made the denominator smaller. If you make a denominator smaller, then the fraction gets bigger. Right? I had 2 cookies, I'm dividing by 1,001 people. Now I've got 2 cookies and I'm only dividing by 1,000 people. It's going to be a little bit more. All right.